Hello and welcome to today's webinar. My name is Stephen Follis and with me is Ray Palmer from AWS. We have the pleasure of working on our containers go-to-market team and Ray is one of our top container specialists, solution architects. And today we're here to talk about one of our favorite topics, which is how we're able to utilize container technology in AWS's cloud services to modernize workloads. Specifically today, we're talking about modernizing content management systems. And so we're going to delve into all the details of what that entails and the variety of benefits that we can offer by taking these workloads forward with AWS. So from an agenda perspective, we're covering a lot of exciting content. So first off, we'll talk about what is a content management system? Why are we talking about it? What's so important about this type of workload? And why does modernization make sense? So we'll get a good starting point there. We'll then move into, how can containers and persistent storage that are running in a serverless fashion, how can that add benefits and agility to our applications? Next, towards the end, Ray's got an exciting demo plan for us. It's going to take us out of the slides and into a real operating architecture, showing all the details of how we're able to implement the conversation topics today. And then we'll wrap up with a couple of next steps and some ways you can learn more about both AWS, AWS Fargate, and AWS Elastic File System. So, why content management systems? What's the big deal here? Well, first off, when we talk about content management systems, we're talking about uh, our applications that make it easy to build, maintain, update content. So instead of forcing everyone in your organization to go out and on nights and weekends learn HTML, CSS, and JavaScript to build their own custom web applications, we can instead power web applications through CMSs. These are things such as WordPress, Drupal, Joomla, and a variety of other applications that make it very simple for operators to update content and create content in a WYSIWYG kind of format. So if you've used Microsoft Word or a text editor, oftentimes you can be very successful very quickly with a content management system. These systems do a lot of additional tasks and wear a lot of hats within organizations. So enterprise content management is one example where content is being built primarily for internal audiences in support of line of business type applications and processes. I think things like intranet type applications that you need for your internal audiences to make sure your organization is educated and performing with what they need to be doing. Additionally, many of these applications are public facing. They're out on the web. There are a vast number of websites today that are powered by content management systems. It's estimated somewhere around 40 to 50% of all applications out on the internet today are running some sort of content management system under the hood. And so these are incredibly prevalent and they're very, very popular for some of these reasons that we were talking about of no coding required, but also the incredible ecosystems that are around each of these products. So there are entire libraries of templates, for example. So when you want a good-looking website, that's one of the first things we come across. We need to have our colors, we need to have our icons, our marks. We want something that looks good with good photos. These templates make it very easy to get a very good-looking site with very minimal effort, and then you can also customize those further based on your branding. Plugins allow you to extend these systems to do all variety of tasks, from taking credit cards for things like e-commerce type sites, to tracking signups, to doing really, if you can think of it, there's probably a plugin out there in some of these libraries for WordPress and Drupal, et cetera, that allow you to do that. Additionally, these publishing tools allow anybody to be able to publish content and do a variety of complex publishing workflows, such as embargoed content where you want to publish on a certain date, you want to trim down different audiences, a variety of capabilities that allow you to make sure that the right people are seeing the right content at the right time. And then finally, these systems help you get eyeballs into your content. So from between social media, being 2021, social media integration is key, so that we're driving customers from social properties into CMS-based applications and vice versa. And then additionally, search engine optimization. This is a biggie in that everybody wants their content to be number one on Google when you type in a certain phrase. Search engine optimization makes that possible. But search engine optimization can be very complex, especially if you are having to manually build out all of the tags and metadata associated with those pages. CMSs do that on your behalf and do it automatically. So it's a very powerful ally in ensuring that your content is raised up as high as possible in search results. And then finally, being able to measure the impact of these sites. So analytics is key, being able to see what pages are popular, who's visiting the page, where are they coming from. Analytics allows you to gauge the impact that content is having. So all of these capabilities of modern content management systems are crucial, both for internal and external to organizations. However, many of these systems are still operating as they have for 10 plus years on one or few virtual machines or even bare metal servers with very limited amounts of storage capacity, making operations hard and expensive over time. So some of the requirements that make this challenging to operate over the long term are things like data availability. So making sure that the data tier for all this content is highly available, is accessible, and is able for teams to be able to scale out as necessary. Additionally, as organizations become increasingly global, we need to have concurrent access for users from all around the globe so that your users in the Americas are having just as good of an experience as those in EMEA and those in APAC and other regions around the world. You're not wanting to have latency getting in the way, and you want to make sure that we're also doing things like internationalization and other capabilities in those platforms to make sure that broad audiences are able to use the site well. Additionally, scale is the name of the game, especially when we talk about public cloud type properties, being able to accommodate the increased demand for scalability of these applications. So, as soon as your product or website makes the news or goes viral on a social media property, can your application be able to scale to meet that demand? I think many of us have been to a website that was popular and we get met with an error message because those web services have been brought down. They didn't have that scale. They didn't have that capacity necessary to serve that content. And so being able to scale is an area that historically has been challenging, especially more of that VM-based approach. Sharing plugins, we mentioned those plugins and themes are great. However, when you go from one server into multiple servers or into multiple containers, having a shared storage to be able to ensure that all of those applications are reading the same data and presenting the exact same look and feel in the same plugins is critical. So we want to make sure that we're able to share all of these capabilities across other containers and not have to update them in 10 different spots every time we need to change a color or tweak a logo. And finally, performance. If research shows that if users can't get onto your page very quickly, they're going to go someplace else. And so making sure that we're loading pages very quickly, that the content and data that we're presenting is available very quickly is of critical concern for these kinds of workloads. So why would we want to be modernizing these systems? Well, the first is speed, right? We want to be able to get to market faster. Ray and I have worked with a variety of customers who run things like brochureware and marketing sites, microsites, and other kinds of web properties that are associated with product launches. Nobody wants to have to delay a product launch or delay the marketing resources around, hey, the website's not quite ready to go, or the website doesn't quite have all the capacity that's necessary. Our data storage is not ready to serve up this traffic. Modernizing these content management systems gives you better speed and allows you to move faster with those apps. Additionally, from an agility perspective, automation is available in most modern types of systems. And when you're using technology such as containers, it's very easy to put together automation end-to-end type platforms that make it easy to test your applications and then iterate and incorporate changes centrally. And so the agility that's offered here is critical to being able to support changes and updates to those platforms as they grow and evolve. Simplicity is one that we hear all the time of, hey, we're spending a lot of our cycles provisioning virtual machines on premises in our data centers, or we're having to requisition more hardware. We've got a lot of heavy lifting that we're working on that really is necessary, but it's not adding to our content. It's taking away from the time that we can spend on the content part of that content management system name. And so from a simplicity perspective, AWS removes that undifferentiated heavy lifting by taking it on ourselves as a platform and providing tools and services that allow you to focus more on your content, less on the underlying infrastructure. And finally, as with anywhere else at AWS, security is job number one. And so, from a security perspective, leveraging security tools and ensuring that the right people have the right access to the right content is critical. So you want to make sure that we are being incredibly mature and sophisticated when we talk about security. AWS offers that and can provide that into these content management systems as well. So, what does the solution look like, or what are we proposing and suggesting today? Well, the solution that we're talking about is taking a content management system, be that WordPress, Drupal, or Joomla, are the three we typically kind of roll off the tongue, but this could be a variety of content management systems, typically systems that have a backend database that need shared storage, and then operating them on AWS in a serverless fashion. And what that means is utilizing a service named AWS Fargate to be able to operate the application tier in a serverless manner, be able to scale out and in on those on the web application tier, and then also Amazon EFS, Elastic File System, which allows us to have a hosted, very straightforward approach to shared storage. So the benefits and some of the reasons why we think this is valuable and what we've seen with customers is that this is simple. Because this is serverless, there are not AMIs to be managing. There's not EC2 instances. There's not virtual machines on-prem. It allows the developers to focus on those apps and not the infrastructure, as we were saying a second ago. So that simplicity is powerful and leads you to have more cycles to focus in on what you're putting into the content management system rather than what the content management system is sitting on top of infrastructure-wise. Availability taps into the incredible global data center region and footprint of AWS. And so, as far as building a highly available application around the globe and even within each region, redundancy and durability are really keys to AWS's infrastructure. Deploying your content management system into something like multiple availability zones, which both Fargate and EFS support, allows automatic failover and a better experience for when there are any kind of catastrophic incidents or failures. You know that your application is not going to be as impacted because you're architecting this in a way that is built for resiliency. Elasticity is all about taking advantage of scaling out and in based on your needs. So with Fargate and EFS, we make it very simple to scale out. That may be at 8 a.m. in the morning when you're expecting traffic. Maybe we need to scale that environment out, scale it back down at 5 p.m. overnight to save cash is one of the canonical examples. You may have a specific event, a launch event that you need to scale out for a week while marketing activities are going on and then ramp down to a steady state. This scaling out and in has historically been complex, especially when we're talking about servers and virtual machines. This serverless approach of Fargate and EFS make this trivial and make it really table stakes and out of the box capabilities here, where you can define the type of scaling necessary for your application, and then AWS can take on that complexity and the pain of being able to scale out and in. We see that this is a key way to being able to be very economical and efficient with your spend as well. And so when there's not massive demand for your customer or for your content, we can scale that down and save money when there's not that demand. Agility is all around being able to share those plugins and themes across containers. What we mean by that is, one container is simple enough, but when you have 10 containers, 15, 100 containers that are all running that we've scaled out, they all need to have a shared amount of data here. So where those plugins and themes can be stored in one location and then consumed by all 100 of your containers. We don't want to be having to go manually update 100 times this exact same CSS sheet that we're changing one color on. So instead, when you're utilizing EFS, we're able to put content in one spot, and so that you update that content in one spot, thus being able to roll that out to all instances in the environment that need those capabilities. And finally, we talked about security. All of our services, AWS, wrapped in our what we call our IAM permissions model. You can lock down who's able to access and work with the infrastructure, be able to have a very mature way of how we're operating from a security perspective, including things like EFS access points that can enforce file system permissions. Is also key when you have multiple different applications sharing a common file system. So there are quite a few security mechanisms that lead us to have a very strong and secure footprint when operating such workloads. So let's talk a little bit more about container services. I know I mentioned AWS Fargate a second ago, but what is Fargate and how does that fit into the offerings that we have inside of AWS? So inside of AWS, we have a variety of container services. We've been building these for many years. We've gotten very, very good at it. And so from a offerings perspective, the first kind of decision to make is around the orchestrator. In the container space, an orchestrator is essentially like an air traffic controller that is placing certain containers onto certain nodes, and they handle the upgrading process when you need to go from version 1 to version 2, and a massive variety of other operational and managerial tasks. From an orchestrator perspective, we have two options within AWS today. The first is Amazon ECS, the Elastic Container Service, which is a fully managed offering right within AWS. It provides really the simplest way to get started with containers. And for users that are very familiar with AWS already, ECS is a great option. The console, the API, the CLI all look and feel very familiar because they were all designed right alongside the rest of AWS's services. And so this is a great starting point and one that we see a lot of users flock towards as really where they feel most at home from an orchestration perspective. Additionally, we have Amazon Elastic Kubernetes Service, or EKS. EKS is a managed implementation of the open source Kubernetes project. And so we run some of the largest Kubernetes clusters that you'll find anywhere in the world on top of EKS. And so EKS is an incredibly compelling option for those customers that have a corporate standard or are working with the Kubernetes ecosystem. EKS is really the best spot for those kinds of applications. So that said, at AWS, you can be successful with either of these orchestrators. They both have pros and cons and trade-offs, and we love support and are continuing to innovate across both platforms. We have customers in production today running mission-critical workloads across both orchestrators. So a lot of it comes down to preference, your requirements, and the pieces that you need for your application. But both of these are options. So now that first, after you pick that orchestrator, the decision comes down to that compute layer. And so historically, containers have often ran on EC2 virtual machines, and that is still very much an option today. However, there's also an alternative inside of AWS that we've been building for several years now that we call AWS Fargate. What Fargate is a serverless compute engine for containers. What we mean by that is that when ECS or EKS need to create a container, they call down to Fargate and a container is created. The virtual machines, the EC2 instances, are abstracted away from the end user, and you don't have to spend the time to build images, to be able to update those images, harden those images. All of that's abstracted away, and so you simply say. Simply hand a container to Fargate, it runs it for you based on what you need and is able to scale out and in based on that capacity that you need there. So Fargate is a serverless way to operate containers that decreases the amount of time you need to spend on updating things like container runtimes or storage plugins. So this is a kind of an overview of the pertinent container services. The portfolio is much broader than this, but specific to content management systems, this is where we find value in taking one of the orchestrators, pairing that with Fargate, and then pairing it with a shared storage system. In this case, EFS is the one that we have found incredibly compelling for these workloads. So EFS, or the Elastic File System, is a serverless approach towards shared storage inside of AWS. So from a serverless perspective, there aren't servers to create and provision and manage. I don't know if anyone has in the on-premises days have set up NFS file shares. Not always the most fun to set up and scale. When it comes out to scaling, typically that means setting up more VMs, calling your hardware provider. Very difficult to scale out. And so we were always kind of careful on managing that capacity and what we needed. And it was always challenging to balance how much capacity do we think we need versus how much are we paying for that, and are we being efficient with what we're spending. In the EFS world, there are no servers to provision. You simply start adding files into EFS, and it grows with you as your data demands grow. So we can scale out and in based on the capacity that you need there. You pay for only what you are using, which also a very efficient way from a billing perspective, and can scale up to petabytes in size based on what you need and as those workloads grow. So from a content management perspective, if you have, so you're saying, hey, we've got gigabytes or terabytes of storage, not a problem for EFS. Not even going to flinch there. It can scale with that. From a AWS compute integration perspective, EFS is very well woven into the compute world. Very few solutions are only compute oriented. We often need to store data, and EFS has invested heavily in a variety of compute options from EC2 to containers and serverless. Um, One of the key points here is that from a Fargate perspective, Fargate actually comes if you are deploying with EKS and Fargate. The CSI driver, for example, is automatically packaged in with EKS Fargate instances. So that's one kind of example of where the EFS and Fargate teams have worked to fully integrate their options. We can also do integrations on the ECS side as well. But this integration is robust, so we can support tens of thousands of connections. So the very the largest content management sites you can think of, where you have thousands of containers, EFS is ready to scale and meet the demands for data for those applications. We talked about the elasticity here, about being able to scale in and out, pay for what you use. That's readily available today with EFS and incredibly powerful. Durability is one where we've got 4 nines of SLA-backed availability. From a durability perspective, we're deploying across different AZs. We can accommodate an entire loss of a single AZ and provide the same quality of service in the other AZs that are available. That means availability zone. It's kind of a bifurcation of our data center regions. So durability is one where your data is safe, it's backed up, it's supported, and is ready to serve when you need it. And then finally, from a performance and cost optimization perspective, performance is key. We don't want data storage to be any kind of bottleneck for your application. So performance-wise, we see tens of gigabytes of throughput, and we have IOPS ready for that IO piece that you need to make sure that the data tier is performing just as well as any other tier within the application. And then finally, for storage classes are an interesting concept here. So for archival content or content that you've had that's been around for quite a while, we can automatically kind of move that to a cheaper tier on EFS to be able to save money. So the data's not going anywhere, but if you're not going to need it, something where that storage class can come in handy as far as saving some money. So how do these building blocks relate to one another, and how do they fit together? So what we have here is a simplified architecture of how these pieces would fit together in a real world solution. So you see we've got a region one, a data center region out in this light blue. Within that region, we've set up a VPC from a networking perspective. We've then deployed a container orchestrator. So this could be either ECS or EKS. We've made this image generic across both. It'd look a little bit different depending on which one you chose, but a lot of commonality between the two. At that point, we've deployed containers with our content management system running in Fargate. And so here we have two different instances that are running. Some nice highly available piece here that's also running across availability zones. And so these availability zones are physically separated buildings in data center regions that allow us to kind of separate those instances out and have a high degree of resiliency. The applications are then calling into EFS through EFS mount targets, and you'll see that those are pointing down into one Amazon EFS instance, and that's that single point where we can update. So if we update a file, we update an image, we update something, a plugin in that Amazon EFS share, both of those containers will automatically be able to serve that data. So we don't have to go redeploy containers every time we make a content update, which is a really powerful and nice piece, especially when we have more than two containers. When we have 220 or 200, this comes in very handy. And then finally, we have MySQL that's deployed for discrete relational data that are often necessary within these databases as well for some of that content. So we see visitors on the left come in through an application load balancer, very standard implementation here inside of AWS Solutions that is then spreading traffic across these containerized content management systems that are then flowing into the data, building a page and returning it back out to that user. So that's a very kind of straightforward kind of look at a reference architecture. To make this a bit more real, we've got Ray who has gone and deployed a very similar architecture into his environment and is going to now walk us through how he built that and some of the interesting components and pieces for that running operation. So with that, Ray, would love to turn the screen over to yourself and please walk us on through your example today.
So thank you for that presentation, Stephen, giving the introduction. I want to ask you a question. Can you guess which year I first created my first website?
That's a great question, right? I would suspect in the 90s potentially. So we're talking like some GeoCities action there.
Oh, you're right. This is 1997. That was the first time I created my website. And obviously, I was in my early teens and didn't have much experience with how to create a website. It was basic website that I basically went to websites and say, right clicked on the website and say, show me view source. And that's how I started learning a little bit of HTML. But it's, very soon I realized that HTML is not going to get me much far. And I started researching. Obviously, back then there was no Google or StackOverflow.com, so I had to rely on Yahoo search. But people told me on the internet that I am going to need JavaScript and CSS and things like um, Macromedia, Shockwave, and Adobe Flash. And obviously, it was very daunting for me. So I didn't get much far, but it was a real world experience of what it takes to create an actual functioning website. Today, a lot of that has been simplified by things like CMSs. And so today, the demo of WordPress that I'm going to show is mostly based on this blog post that I wrote a couple of months ago, which is running stateful workloads using EKS and Fargate and EFS. So I'm going to jump really quickly into the architecture that you presented, that you talked about. And this is an EKS specific architecture. It will be very similar if you had to do the same thing in ECS, but I just chose EKS because EKS is a little bit more components that you need to install before you can use things like load balancers with Fargate. So, but you can do the same exact thing with ECS as well. Just to give you a little bit overview, the way it works is that you have an EKS cluster that we're going to create. And then within that EKS cluster, there's a Fargate profile. And that Fargate profile basically is attached to a namespace, and any pod that I create within that namespace will actually run on a Fargate node. So what that means is in my EKS cluster, I have no EC2 instances at all. As a matter of fact, I'm going to show you some of the things that we do here in this post. I'm going to actually use EKS cuddle to create a cluster. Now, I have already created a cluster because creating the cluster takes about 5 to 10 minutes, and I don't want to waste a lot of time here on the webinar. So I have created a cluster, but I just want to point out how easy it is to create a cluster with EKS cuddle. So in just these lines, these 5 lines, I have created a cluster that's a Kubernetes 118 cluster, and I'm creating it in a different region than my default region. For this demo, I've chosen the Ireland region, and then I'm using this dash dash Fargate option. And what this dash dash Fargate option does is that it patches core DNS to be able to run on Fargate. So typically, if you look at the typical core DNS deployment, it requires an EC2 instance. This option in EKS Cuddle will automatically patch the core DNS deployment to run on Fargate. And that's really all I needed to do to create an EKS cluster. So it's super simple to create EKS cluster using EKS Cuddle. But if your organization uses Terraform and CloudFormation, this is also very straightforward process there as well. So what I've done so far is I have already deployed certain components. So I have a VPC that actually the VPC was created by EKS Cuddle. So again, going back to this command, when I run this, it creates a VPC and it creates subnets and internet gateway and NAT gateways. All of that is already created. It kind of assumes that you're starting from scratch. So which is great for demo and great for starting a new cluster if you don't have a VPC or if you don't have a VPC that you can reuse with your EKS cluster. So then apart from that, what I've also done is in addition to creating the cluster in VPC, I also deployed an RDS MySQL instance, which is used to persist WordPress settings. So as you can see here, I have a MySQL cluster that I'm running inside my VPC. Now, a note here, this is just a single instance, so it's not highly available. In production use cases, I recommend using a multi-AZ deployment so that you have another MySQL read replica available in another availability zone. And in case something goes wrong with the first instance, RDS automatically fails over to the second instance in the second AZ. So that's what we have created so far, which is RDS MySQL cluster, EKS cluster, and a VPC. I've also installed the AWS load balancer controller. And the reason why I did that is to expose WordPress applications using an application load balancer. So as you can see that I have an ALB that's pointing to each one of these Fargate pod that runs inside my EKS cluster. And I am not going to create, when I create this cluster and when I deploy WordPress into it, I'm not going to create a load balancer outside of my EKS cluster. I'm going to use Kubernetes components to also deploy and configure an application load balancer. So all of that functionality is included in the AWS load balancer controller. Okay, so with that, now what we need to do is go ahead and create an EFS file system, which is going to persist the data for WordPress. Then we'll deploy WordPress itself, and then we'll create an ingress that's going to expose the WordPress service that runs inside Kubernetes using an application load balancer. So first thing I'm going to do is I am going to just come here. Let me clear my screen. And first, I want to deploy my EFS file system. So I can just go to my EFS console and create a file system, but I do have some commands here that I'm going to use to actually deploy this file system. So with this command, what I'm doing is I'm creating an EFS file system. I'm just giving it a name. The performance mode is general purpose. This is good enough for my low traffic website. If I needed to get more throughput, then I can change the performance mode and the throughput here. And that's it. Once I do that, I will have an EFS file system created here. And now I'm ready to start using this EFS file system with my applications. The next thing I'm going to do is I'm going to create an access point. And you touched a little bit about this, Stephen. But an access point, what it does, it really gives an application-specific entry point to the file system. So over here, what I'm doing, in the file system that I've created, I'm saying I want to create a /bitnami path. And any application that is going to use this particular access point is automatically going to start writing to this bitnami path. So if I go back to my EFS console in my file system that we just created, I have an access point, and this is the access point that I'm going to reference in my pods to give them a persistent volume. Next up, what I want to do is I want to now create mount points. And EFS mount points are basically endpoints within an availability zone that can be used by consumers like EC2 instances or containers to mount that file system. So right now, as you can see, I have no mount targets. Typically, I want to create a mount target in each one of these availability zones where I operate. So the idea is that every container, every EC2 instance is using EFS, is mounting EFS by using the local mount point in that particular AZ. So what I'm going to do is I'm going to now create some EFS mount points and mount targets. And I'm going to actually use the Fargate profile to determine what are some of the subnets in my AZ. in my VPC, and then I'm going to create a mount target in each one of these subnets. So it's just going to loop through each one of my subnets and is going to create a mount target for that particular file system. So I have 3 AZs in this particular VPC, and so that's why it's created three particular mount targets. And if I refresh here, I'm going to see that this new mount target is being created. Each one of these mount target is also going to have an associated security group. I've already pre-created the security group, but essentially what it allows is it allows you to control who can mount this particular EFS file system. In this case, in my particular security group, I have just opened it to the entire VPC, but in production scenarios, I can imagine that that's either tied to a particular subnet, or in case of if you're using EC2 instances, you can also associate security group with that as well. So with that, my mount targets have been created, and this may take a few seconds, but I'm going to move on. The next thing that I want to do now is we go back here, and now I want to deploy the actual WordPress containers. So for that, I'm going to use the Helm chart. Again, going back to the blog post that we created, I have we're just going to use this Bitnami chart to deploy application. And if you're not familiar with Helm, Helm is a really cool tool to deploy applications into Kubernetes, and it really makes it easy to deploy not just a particular pod, but anything that's included in it. For example, in this Bitnami image, for example, in this Helm chart, you can actually deploy the entire WordPress stack within a Kubernetes cluster, including the database. So in our case, we're just using a MySQL cluster, but if you wanted to create a database that runs inside your Kubernetes cluster as well, you could just use this Helm chart to deploy that database as well. And so this is basically, I'm showing you the values that you can customize. I haven't customized much in my case because it's a fairly straightforward implementation of WordPress. The only thing that I've customized here are the database values and the values for the share that I've created. So the first thing I want to do now is I want to create persistent volume for my pods. So for that, I've created a YAML file, and I'm calling it the EFS persistent volume file. And this, we deploy a couple of things. So first of all, we create a storage class that's based on EFS. I also create a persistent volume. And a thing to note here is that even though in this persistent volume, I'm declaring 100 gigs, EFS grows as you continue to add data into the file system. So the file system that I'm going to create is not going to be a 100 gig file system. It's going to grow as I continue to add file. Now, what I need to do here in this persistent volume file is that I need to go ahead and update my file system ID and the access point. And this is going to basically tell Kubernetes which access point and which file system to attach to the pod, which is going to use this persistent volume. So let me go back to EFS, and I can see that my file system here is here. So I'm going to just copy it here, and let me just delete this and paste it here. Next thing I want is the access point. Now this part is actually optional. You don't have to provide an access point, but I consider it's a good practice because it forces isolation within an EFS file system. So I'm going to do that. So I'm going to go back to access points, and I'm going to just copy this access point ID, and I'm going to put it here. So let me just delete this placeholder text, and Now I'm going to save it. And I'm going to just show you one more thing. I also have a persistent volume claim that I've created, although this is not going to be used. But if you're wondering what else is in the file, that's what is there. Now I'm going to do kubectl apply persistent volume. And what that's going to do is going to create my storage class, my CSI driver object, and the persistent volume and volume claim. Now, if you were to do this in EC2 instance, you would also need to install the EFS CSI driver, but because this is on Fargate, we don't need to install the CSI driver. All we need to do is create this CSI driver storage object, and that's how Kubernetes EKS will discover whether this that Fargate has pre-installed the CSI driver. So you don't need to install the CSI driver. That's the bottom line. So now that I have my persistent volume created, let's go ahead and see the persistent volume here. So I have a persistent volume created, WordPress, EFS, PV, okay, and there's a claim here, but I don't have any pods yet. Okay, so no pods deployed here. Next thing I'm going to do is I want to use Helm to deploy WordPress itself. So for that, as I showed that there's certain values that you can customize in the WordPress Helm chart. So I've done that. I've created a little configuration file with the values in it. So first thing here is the external database. This is the endpoint of my RDS cluster that I created earlier. Very straightforward. The commands to create the actual RDS instance are again in the post. So for those who are interested in using it, you can find the code there. Over here, I'm just saying that I'm going to have a 3 replica count. So when I deploy this Helm chart, the WordPress deployment is going to have three replicas. Next, over here, I'm showing in my persistence. I'm saying that use an existing claim because I've already created it. This is the existing claim that I just created. WordPress EFS uploads PVC. So that's the claim that we just created in the last step. Over here, I'm saying cluster IP service. The reason why I'm doing this is because I don't want to expose WordPress pods using a load balancer type service because I'll be using an ingress object, an ingress to expose the WordPress pods. And then the last thing I'm doing is I'm going to declare the resources that my Fargate pod is going to have. So by declaring here that I need 1,000 vCPU and 1,024 or 1 gig of RAM, this is how Fargate is going to size my pods when it creates them, and that's how I can control how much CPU and memory my pods are going to get. So with that, the next step I'm going to do is I'm going to use this Helm chart to deploy WordPress. So what I'm saying is just using my values file here that I'm showing you, and then I want to install Bitnami WordPress. Okay, in the meanwhile, let's go and make sure that the access point and the mount targets have been created properly. I'm going to go back here. And in my network, I should see 3 mount targets, all 3 of them available here. As you can see, each one of them is in a different AZ and using a different subnets. And it has an associated security group that allows inbound NFS traffic from the VPC. Okay, so now the Helm has completed the deployment. So now I should be able to do get pods, and I should be able to see at least 3 replicas pending. So that's pending. That means that pod is still being created. It takes anywhere between 40 seconds to 80 seconds to start these pods on Fargate. And what's happening in background is right now Kubernetes scheduler has requested that it wants to run these 3 pods, and now Fargate is creating infrastructure in the background to run these pods that are currently pending. So these it's going to remain pending. I'm just going to put a watch here, and I am going to go back to my EKS cluster. Okay, and going into my clusters, I have a cluster, which is this EKS Fargate stateful cluster. It's a 119 cluster. And over here, you can see that I have 3 nodes that are running. Now, these 3 nodes have been running for 17 hours, so they're most likely running my core DNS pods. And if I actually go in here and do kubectl get nodes, then I'll see the 3 Fargate nodes in addition to the new nodes that have started to run the WordPress pods. So let's get kubectl get pods. Let's see if the containers are running. It looks like container is creating, and this may sound like I may have some problem here. So I'm going to just do a describe here to see why my pods are not running. Of course, a live demo, and this is to be expected. Okay, so it seems like there's some configuration problem in my volume file. So I'm going to just look at my EFS persistent volume file. And I'm going to go back to EFS. And I'm just going to verify, oh, it looks like I have a typo here. So I'm going to just edit this file, and it seems like I copy pasted the wrong values somehow. So my volume handle is not the volume handle, or perhaps I didn't save this file. I'm not sure, but it's a good way how to troubleshoot these issues. It's a good way to find out troubleshooting EFS issues with EKS. So let's just make sure. So I have the volume handle correct. Let's go back and check my access point. I believe that should be a correct one as well. Okay, so that is correct. And I am going to just save it. And I'm going to just do a helm delete my post, my WordPress installation. And I'm also going to do kubectl delete the volumes and the persistent claim that we've created. Then I'm going to do a kubectl apply, same thing again, which I just deleted. So this time it should create a new persistent claim, hopefully with the correct file system. And then again, helm install, we're going to do the exact same thing. Okay, and now Helm has deployed WordPress. So let's just do a kubectl get pods, and I should see 3 replicas pending. Now this may take another 40-50 seconds. So I'm just going to pause here, put a watch, and wait until they're in creating or running condition. Okay, so it took a little while, but we were able to now get the pods running. So now if I get kubectl get pods, I should be able to see those 3 replicas running. And yes, we can see that they're running. And now the only thing that's remaining is to now expose this this service that the Helm chart creates. So let's just say get service, and it should show the WordPress service that we're running. here. This is going across to Ireland, so that maybe a little bit delay between Seattle and Ireland. That's why you see a little latency in the response. Okay, so now I have a WordPress blog service created. I've also created an ingress already. And so I'm just going to show you the ingress that I've created. And I also have a manifest file that I'm going to walk you through. So this is the address of the load balancer where my WordPress service is running. Let's check out the ingress. So ingress is very simple. It's nothing complicated. I'm just saying that you have ALB, and basically anything that lands on this ALB, all that traffic should be forwarded to the my blog WordPress service that I'm running. So I'm just going to get out of this and okay, and now I will get the actual host name. So I'm just going to get the host name from the ingress that I have created. So I'm going to use kubectl to get the host name. And then once I have the host name, I can take here and copy paste it here. I already copy pasted it here because I created the ingress prior to the demo, and it doesn't change unless I delete it. So I already have the ingress here. Next thing I'm going to do is I'm just going to log in. I have a password here that I've used to create this particular WordPress installation. So let's see. Copy this and paste it here. And there you go. So this is now going back to the 3 pods that I'm running. What I can do is I can make some certain changes here. For example, I can go to the settings, and I can go to the appearance and change the themes here. Let's do that. That's better. And I'm just going to say I'm going to use this 2020 theme. Now what I can do is, even if I go ahead and stop these containers that I have, for example, I can go ahead and scale these containers to 0. So that's what we're doing here in this post. So let's try to do that. I'm going to scale my WordPress deployment down to 0. Some copy paste problems. And I'm going to run this down to 0. And then I'm going to, once all the replicas have been destroyed, I shouldn't have any pods running here. Yep, no pods running. So now I can turn it back to 3. It'll create 3 new replicas. And when I get back, when the replicas are back up and I go back here, right now I'll just get a 503 because none of the pods, none of the backends are functioning yet. So I'm just going to do get pods and watch here. And once the pods are up and running, I'm going to go back to my WordPress website, and it should not give me a 503. Instead, it should again send me to the admin portal where we were before. At the same time, the theme change that I did should persist. Now, typically, what is the EFS file system used for? EFS is used to store anything that's stored in this containers /bitnami path. So those are typically any uploads, any media that you upload, any content that you write, all that markdown text and images, those are all going to be stored in EFS, in the EFS file system. And that's really good because if you go back to EFS, and you talked about this, Stephen, that EFS has this infrequent access mode, which means that if you have a blog that you've been writing for years and years, eventually a lot of that content is going to become stale or wouldn't be needed too frequently. And at that point, what you can do is you can create a lifecycle policy here, and that automatically moves content that is not frequently accessed. So I can go ahead and create a file system policy to say that automatically start moving data and files that have not been accessed for some time. So that way you can save some money on save some amount of money that you spend on EFS as well. Going back to our pods, looks like these pods are almost up and running. They're still not coming. That takes a while once the pods are running, just to connect to the database. So we can actually go and look at the logs here for one of the pods. Okay, and if I go to the logs here, I should be able to see some access logs, some database connection logs. And as you can see, the site is up and running, and I have the theme chain that I made, and it has persisted even after I scaled the WordPress site down to 0 and scaled it back up. So again, as the site gets more and more traffic, you can also configure this to use auto scaling, where you have horizontal pod autoscaler that can scale the number of pods. You can also improve this WordPress architecture by having CloudFront to kind of just have a CDN in front of your load balancer, which caches all the static content, which just improves the user performance, user experience on the site. And then you can also use things like memcached or Elasticache to implement a caching layer between the database and the WordPress. So with that, I would conclude the demo and pass the baton back to you, Stephen.
All right. Thank you, Ray, for that incredibly detailed walkthrough. Great to see these content management systems coming alive like that with utilizing EKS, Fargate, EFS, and the rest of the services underneath the AWS umbrella. So appreciate your time there. So um, one other piece I wanted to mention and call out today is just to highlight one of the customers that we've worked with that is experiencing these benefits today. So Acquia is a company whose core business is hosting content management systems. They host Drupal-based websites for enterprises. They have a lot of them, thousands upon thousands of these websites. And so what they were trying to do was figure out, hey, how do we get a better stance around how we're going to scale these applications to improve our end users' digital experience? And so to be able to accommodate that, they move towards what we've been talking about here today, utilizing EKS, utilizing EFS, and pairing those two together to be able to get a much more efficient way of operations. That's led to more dynamic scaling of those environments. It's led to more economical uses of cash when it comes to what they're paying to operate. Let's reduce the amount of burden that they've had on their operations teams that administrate the platform, ensure that things are up and running, and deal with the operational pieces. So this is one of many customers that is utilizing this pattern, and we hope that to see your company's name up on one of these slides here soon, following in these footsteps. All righty. So to wind down, first off, appreciate everybody's attendance today to be able to watch in on this content. As far as some next steps, wanted to provide some links that may be useful. So at reInvent here, just about a quarter ago, or back in the November-December timeframe, we had a presentation and a series of presentations around modernizing applications. EFS it was core to many of these stories, and we've got a link here that walks into a variety of these stories. Additionally, there's a developer's guide for EFS on our container storage blog. We have blogs from Ray that he mentioned earlier around utilizing content management systems with Fargate and EFS available. And then finally, one of my favorite pieces is that I would encourage you to take a look at the ECS and EKS workshops. These are interactive, self-guided resources online, where as long as you have an AWS account, you can spin up an environment and follow along a series of step-by-step lessons that are a great way to get your arms around the technology and really learn how these pieces fit together there. Both ECS and EKS workshops have sessions around integration with EFS. They're not specific to content management, but they do talk about how to do stateful workloads with those particular orchestrators, and also have activities of integrating Fargate there. So they do a great job of integrating those pieces. So with that, thank you again for your attendance. Please reach out to your AWS account representation if you have additional questions and want to hear more and learn more about our container services, our storage services, and how you too can modernize your content management system applications by utilizing the services within the AWS cloud. Thank you and have a wonderful day.